the linear function y is equal to negative 1 over 2x plus 4. When the intersecting point P exists on the coordinate plane, solve for the maximum value of area of the triangle PQ0. First of all, if you think about the term maximum point, we can obviously relate this to the vertex. And for the vertex, we can also relate it through our function, but especially for our quadratic function. So actually, let's think about the term vertex throughout our function's properties. So it will going to be a format of a graph or a quadratic function, and there are two cases in our quadratic function, and they're all defined by our leading coefficient, which we usually notate it as the a. The first case in our quadratic function will going to be the case where our a value, our leading coefficient, is greater than 0, which means when it is a positive value, the graph of our quadratic function will open, or we can say it goes upward. When the quadratic function's graph opens upward, for example, it will look something like this, that keeps going toward upward and never intersects at some point, but then you're going to contain one specific point, which is most important point in our quadratic function's graph, which we usually call it as the minimum or the lowest point on our quadratic function, and this will occur when our a value is positive value. The second case in our function will going to be the case where our a value, our leading coefficient, is negative value, which means when it is less than 0, the graph of our quadratic function will totally opposite with the first one, which means the graph will go downward or opens downward. When the quadratic function's graph opens downward, it is exactly the same thing except the direction where it is going will going to be different. So here it will contain another most important point, which we call it as the maximum point, over the highest point on our quadratic function, and it will occur when our a value is less than 0. From here we can think about or relate the vertex. So if you think about what the vertex term will look like, it will going to be the same thing with adding the number of possibilities between the minimum point and the maximum point. For a point P, which is the intersecting line between this linear function and the P point on the triangle, and we're trying to solve for this triangle P0, Q is the maximum point or a maximum value of our area of the function. So secondly, we need to think about how to solve for the area of our triangle. Before that, let's think about how to solve for a point P. So any kind of coordinates on the coordinate plane is basically formed by x comma y. So if you think about what the x and the y will going to be, x value will going to be the input of our specific function, and for that y value, it will going to be a specific output of our function. Since we inputted input, so it is going to generate the output. And using this x and the y, we call it as the function. And the function should always require a specific input as well as the output. And for that p, it shares exactly same x and the y coordinate. And for the x is the input and the y is our output. The y value here, as we have learned, the y value will going to be the slope of function. But then if you think about it, we could not solve for the first slope, so it's not slope. So it was going to be a output, the thing that we can see from our any function. But in this case, our output function will going to be y, but it says y is equal to negative 1 over 2x plus 4. So our y coordinate in this case will going to be negative 1 over 2x plus 4. And the reason why we could write it like that was because our y value output was exactly same with our answer, negative 1 over 2x plus 4 from our information. And So for the coordinate, it will going to be x comma -1 over 2 x plus 4, where x is our input, and -1 over 2x plus 4 is y value, which we also call it as the output of our function. For the area of the triangle, the formula for solving for the area of the triangle, we're going to be base times height divided by 2, or multiply by 1 over 2. So this will going to be basic area, and for the x value in our coordinate plane, it will going to be a baseline. For our y value, we're going to be a height of our function. This is the reason why we solve for our p-value, because it is a point that satisfies our base and the height. And if you multiply together, and if you multiply 1 over 2, we're going to get our total output of our function, and our output of our function will turn into the area of our triangle. So first of all, so our y value was output, -1 over 2x plus 4, and our x value was input, which is just x because it is an unknown variable which we cannot figure out. So from here, we can actually apply our area for a triangle. Base was going to be the x, and for that x, we have our height, and our height we're going to be our y value, which we're going to be -1 over 2x plus 4. And then if you finally multiply 1 over 2 or divide by 2, but then in this case they're multiplying, so we need to multiply 1 over 2, which we're going to make the calculation easier. And if we solve for it, it will going to be our total area of our function. So if you multiply 1 over 2 to our x value, and you raise our 1 over 2, we're going to get 1 over 2x times -1 over 2x plus 4. But we are only multiplying 1 over 2 to the 1 time, because it can't be a constant. So it will going to be -1 over 4 x squared plus 4x. But we're gonna get it wrong because we are using our distributive property, which means we need to change also into 2x. So from here, since we knew that it's x squared, it will going to be a quadratic function. And the reason why we talked about the quadratic function's graph form is because it is related to quadratic function. So from here, let's think about how to solve for our vertex of our quadratic function, because our vertex will going to be either the minimum or the maximum point of our vertex. But since we knew that it is a maximum point, that means our leading coefficient is equal to negative. The first way to solve for our vertex of our quadratic function is convert the standard form And if you think about what the standard form will look like, standard form is a basic structure of the format in our quadratic function, which will going to be y is equal to ax squared plus bx plus c. This will going to be our base structure of our standard form. But in order to solve for our vertex form, we will convert this into a vertex form. In order to solve for our vertex in our quadratic function, which means we need to think about what we're going to be our basic structure of our vertex form. And it will going to be y is equal to a times x minus p squared plus q. And if you think about what these variables does in our vertex form, y should always be the output of our function. X will going to be an input of our function. And then p value will going to be the x coordinate. The x coordinate of our vertex. And the q will going to be the y coordinate of our vertex. This will going to be what each variable does in our vertex form. There are totally 4 things. So in order to solve for our vertex form, in order to cover standard form, the vertex form is the same thing with the perfect square form, which means the same thing with the completing the square. So if you actually think about what our standard form is, our standard form will going to be y is equal to -1 over 4 x squared plus 2x. And we need to convert this into a vertex form. So first of all, we need to make our leading coefficients equal to 0 in order to solve our calculation or recalculate faster. In order to do that, we need to multiply every single term by -1 over 4 in order to make our leading coefficient equal to 1. So it will going to be -1 over 4 times x squared. And then it will going to be minus 8x, and there will going to be a sum constant. So in order to solve for constants for our formula, we're going to be half of our coefficient in the square, which will going to be a positive 16. But if you use our distribute property in order to distribute our -1 over 4 to our 16, it will going to give us -4. But if you just add -4, it will going to affect our total function, which means we are adding a 4 back. So from here, we can actually make our standard form into a perfect square form. And there's a whole point of doing the vertex form, which will turn into y is equal to -1 over 4 times x minus 4 squared, and we still have our constant left, which will going to be a positive 4. So this will going to be our vertex form, which is optimized when it comes to solving for our vertex. So our vertex in this case will going to be the maximum point, since we knew that our leading coefficient is -1 over 4. And our vertex of our quadratic function was p comma q, where p is the x value and the q is our y value. So this will going to turn into 4 comma 4. And then 4 is a y value, which always should be a constant without variable. So 4 comma 4 will going to be our variable, or vertex in our quadratic function, which means our answer for this question will going to be our maximum area of triangle will going to be when x is equal to 4 and y is equal to 4.